Hello, everyone. Welcome to our Let's Talk webinar for the NEC Immersion Plus event. Today, I've got with me Dave Arthur, who is the F5 ANZ Security Solution Architect. Myself, Rob Evans, I'm the NEC Partner Manager. And today, we're going to take you through a topic talking around the next generation secure information gateway and what it can mean for your business. So to kick into it, I'll pass over to Dave. But first, I might ask a question around Dave. What's the background and context for your work in this area, in the next gen secure information gateway area?
Thank you very much, Rob. So for those that don't know me, my name is Dave Arthur, Security Solution Architect for Australia and New Zealand. And part of my background includes working for in Canberra in the Australian federal government space. And whilst I was working down there, I was doing a lot of work on secure internet gateway architectures. Now these working for a managed security services provider that would then offer as managed services to the Australian federal government. Now, these gateway environments were IRAP assessed and AST certified up to the level of protected, which meant that we could utilize these services to separate untrusted, say, internet traffic from up to protected classified data and information systems. So working on those in that environment, providing these managed services to government, what I realized is that the old firewall sandwich architecture that we've adopted and been utilizing for the last, say, 20 years or so, and that we still see around a lot of environments today, was just not suitable for today's threat landscape and the changes in technology and social trends as well.
So I guess, Dave, in that regard, I mean, what's changed in recent times around threat landscape and the technology trends? I guess, can you maybe comment a little bit on that?
Yeah, certainly. So there's probably four main trends that I'll talk to, and the first trend is really when I was doing this work in federal. I was initially focused on floods of traffic. Now that doesn't necessarily just have to be floods of attack traffic like DDoS attacks and the like, which we certainly saw our fair share of. Sorry, but it's also floods of legitimate traffic as well. So it could be campaign traffic. So for example, we were hosting the Murray-Darling Basin Authority's site at the time. And so when they released their plan, it obviously drove a ton of legitimate traffic to those sites as well. And plenty of other performance testing that we were doing for very high scale sites at the time as well. And what we noticed was that the firewalls that were sitting at the front door were just melting under the load of these really high volumes of either attack or campaign traffic. And what we also had, the epiphany was that these firewalls were literally, they were good at stopping traffic. That's what they're designed to do, but they weren't good at processing very large volumes of traffic. And when most of the services that we were exposing to the internet were over the web channel, so port 80 for HTTP or port 443 predominantly for HTTPS, those firewalls at the front door were doing nothing except for being a bottleneck. So we actually, what I talked at the time, I said, let's flip the architecture. So what we actually did was we brought F5 in to do the front door piece. So do the really high scale volumetric services at that front door. And I like to call it the bouncer at the front door, the big guy that stands there and says, not in those shoes, mate. Off you go. Just get the riffraff and the white noise of the internet out of the environment. Before we then pass a subset of the traffic down to the enforcement point, so your next-gen firewall that was sitting in behind us. So that was the first iteration of dealing with flood traffics, but then the next part of it was, okay, CIOs were then starting to externalize a lot of their services, so they were starting to adopt a lot more SaaS and a lot more public cloud. And these kinds of programs of work really dramatically changed the traffic profile of what transits your gateway. And so it wasn't just floods of traffic coming into the environment, it was being able to scale the gateway services to cope with floods of traffic going out of the environment as well. And so we needed a smarter approach with what we were doing there. And then if we fast forward some years and we talk about the trend in terms of the adoption of encryption, encryption is, for services going in and out of our gateway anyway, it is pretty close to ubiquitous. Most of my customers are at 80+% of the traffic going through their gateways encrypted. But it's not just the fact that it's encrypted, it's the quality of encryption that's being utilized as well. Modern encryption protocols preference perfect forward secrecy, which means that if you're not active in the communication, then you're not able to adequately inspect that traffic. And even if you can provide some sort of normal inspection capability, you're probably not doing it in a sufficiently secure way, and it's leaving you open to evasion techniques. And then the other part of that as well, when we talk about having these services being expanded greatly in terms of Office 365 and other SaaS adoption and the rest of it, to cope with encrypted traffic egressing our gateways and doing it in the old daisy chain approach where you had each service in a line, it meant you had to scale every single security technology in your gateway as that traffic profile changed, which is not very efficient at all. So what we did was we leveraged again F5 to do that centralized TLS intercept and inspection point, and then provide the traffic in the clear through all the various different services that we needed to inside the gateway environment. And then if we look at some of the other, the tech and social aspects as well. So, we definitely see that the rise of the webification of applications. So businesses are really transforming a lot of their applications into web apps if they weren't already, and exposing a lot of their business processes via these web applications as well. And then obviously remote and mobile workforces has dramatically increased, particularly in recent times with the whole COVID situation and not being able to physically attend offices. But even prior to that, the adoption of mobile and remote workers was growing rapidly. So we have this sprawl of applications all over the place, and different ways to access those applications and different authentication mechanisms and like. So you need a way to be able to basically untangle that spaghetti ball of mess and bring some sense and logic back into what you're doing there, and some centralized control. And then one of the other components that is really, really important is that the applications have moved up the stack. The attacks have moved up the stack, and they're now targeting applications. So maybe 10 years ago or so, we were really focused on network-centric security, making sure that we had source IP, destination IP, port protocol locked down, and we had these access control lists to try and restrict people's access to systems to try and stop them from compromising them. But again, with the webification of applications and the conversion of business processes and exposure of these as web applications to the internet, that has totally changed. We have to make these available to pretty much everyone on the internet, or at least we can only provide some really basic sort of controls into what sort of users get to access these applications from external, and they're all over port 80 or 443. Right, so the firewall again is that network-centric approach now is doing nothing, and attackers have realized this, of course, and so they target the application up at the application level. So we need the ability to be able to ensure that we're protecting those applications from themselves in terms of vulnerabilities that they have inherent, whether that's because of the developer making coding mistakes or a problem with the infrastructure stack that's supporting the application, like a vulnerability in the web framework or the server technology. But then what we're also seeing is more and more attackers moving beyond just trying to break through the back door, if you like, of an application, smash a window and break into it, and moving into looking like they're a perfectly legitimate user and walking through the front door with a key that unlocks the door, and then causing abuse to that application, or abusing the business logic to create an undesirable outcome for it, or even committing fraud against that application for financial gains. And so if we draw an analogy to this is what I like to talk about, is that if we're an attacker and we're trying to exploit a vulnerability in an application, then we're really trying to kick down the back door. We're trying to break the application, get in by some brute force kind of mechanism, right? Or maybe not brute force, but force mechanism. Whereas if we look at the left there, this is really a great example of somebody taking over an account and impersonating a perfectly legitimate user, coming from a device that looks like it's the user's, or if not a perfect replica of that user, coming from a perfectly legitimate geographical location and utilizing their credentials, their key to get in through that front door. And they're really difficult attacks for people to be able to try and sort out the attacker from the legitimate human customer.
Yeah, I guess with all the all the phishing scams that are out there, and the fact that these large databases of stolen credentials, I guess this sort of impersonation attack's going to become more and more prevalent, right? These days. Well, that's some great insights, Dave. I guess what are, I guess, F5, and what sort of solution characteristics are required to sort of address some of these changes? And I guess where does F5 and other vendors play in that sort of space?
Yeah, it's a great question, and I really want to highlight the point you say at the end there. Other vendors. Right? There is no silver bullet in the security space. There is no single capability, no single one thing that will solve all the problems. If there was, we'd all just go out and buy it and job done, right? But that's not the case. There's the security spectrum is extremely broad, right? And it requires a mindset of defense in depth, and we need to look at the capabilities that different vendors have, the strengths that they have, and the differentiation they have to put multiple vendor solutions together to work in unison, as opposed to looking at sometimes quite small areas of overlap that the two different technologies may have, or two different solutions may have, to pick one versus the other. And so this is what I've been working on in terms of having this multi-vendor approach. So what we do in this is we call out the places where F5 is extremely strong and where you absolutely should use F5. And then we call out areas where we have no capability. We don't even pretend to have capability. So for example, we're not a fully fledged next-gen firewall. We're not an advanced threat protection solution. We'll never have a sandboxing capability. We're not good at letting traffic stop and sit at rest to do inspections. Everything we do is around ensuring that traffic keeps moving. So when we talk about our strengths, I talk about utilizing us as like I say, that bouncer at the front door to do those border filtering services, things like shutting down DDoS, automation at the front door, just getting the junk and the white noise of the internet out of your environment. And then leveraging a fully fledged next-gen firewall as the enforcement point that sits in behind us. So, whether that's Palo Alto, Cisco, Checkpoint, whatever your flavor of next-gen firewall is, and let them do that more intelligent level of network security analysis with their IPS, their threat intelligence services, their application identification and the like. And then in behind that, we then have a third tier of F5 really doing those. Again, this is another really strong strength of ours, is the application assurance or application protection services. And that's where we're doing really, really detailed analysis into the web protocols and looking for, again, those exploits in terms of people trying to break into the application, or people trying to commit automation or manual fraud against our applications. And so that's on the inbound use case. And I like to refer to it as a funnel. So at the funnel, we're just getting rid of the vast majority of traffic out of our environment. We send a subset of the traffic down to the next-gen firewall, and then a subset of traffic again down to that application layer set of controls. Because when we get down at that level, we want to ensure that that security inspection point, the F5 Advanced WAF, is only processing the traffic that it absolutely has to, because it's computationally expensive, and you want to be ensuring that you get the best leverage and the best value of each of your controls at each of these tiers. And some people talk to me and they say, "Oh, this looks like it's going to increase our costs, because we've got multiple vendors in the mix and all the rest of it." But because we're actually delivering a really efficient design, what you'll notice out of when we get to a real sort of sizing exercise and looking at what the end solution looks like, because we are taking this pragmatic approach and we're utilizing each tier for its best value, you're actually reducing the size, if you like, or the investment of each of these tiers, because each of the more expensive tiers that are doing really detailed inspections aren't having to process this junk traffic that should just get cleared out by the tier above. And then
sorry, I was just going to say, and I guess also would F5 also play a part in being able to scale out each piece of the architecture independently, so it can, I guess, just be sized, as you say, for the right amount of traffic for that particular security control.
Yeah, exactly. Absolutely. And the other really powerful part of this solution as well is that everything that is inside the inspection zone here, whether it's from an inbound flow or an outbound flow perspective, because of our heritage in terms of being able to do traffic management really, really effectively, you don't have to run these services as active standby anymore, because we'll identify if there's a failure or if there's a performance degradation or whatever with one of your controls, and we'll actually just steer around that problem. Or we can fail close if required as well. But it also means that you can then go from active standby, where at least half of your infrastructure is sitting around doing nothing at any given time, and you can move to a far more efficient N+1 scale model. So one of the other things I'd like to talk about just quickly as well is just revisiting it's not just outbound, but revisiting the visibility into encrypted threats. So one of the other things that gives us a lot of strength is our full proxy architecture. And this is another area where I say that you should absolutely be leveraging F5 for, because hand on heart, not just an F5 person, but from previous years of experience as well, that we have the best capability in terms of being able to provide security services around encryption of, but also inspection of encrypted traffic. And the way that we do this is through our full proxy architecture. And it was almost when we talk about encrypted traffic, it was almost a happy mistake, not a happy mistake, sorry, an unforeseen benefit of moving from the half proxy architecture we had 20 years ago to a full proxy architecture. And that was a significant body of work that we had to go through. We went into sustaining mode for our legacy product, and we only did bug maintenance fixes, and we had a very small proportion of our product development on that side of the house. And we threw the vast majority of our company's resources at totally re-architecting our platform to go from half proxy to full proxy. And it almost broke the company. It was that massive an effort. But when we came out of it on the other side, we actually transformed the load balancing market into the application delivery controller market. And the reason we did that is because we ran a full application stack on each side. So every time a client comes to us and talks to us, we are the server to that client. And then on the other side of the conversation, we are the client that is talking to the real server. And that doesn't matter inbound or outbound. And so that gave us great performance improvements, and like I said, allowed us to transform the market at the time, and it gave us true application level fluency on each side. But if we fast forward to the encrypted threats visibility challenges, the only way to be effective at handling even the current protocols and ciphers effectively without being subject to avoidance and bypass techniques is to have that full proxy architecture. And that's right now. And if we then look into our glass balls, our crystal balls, and look into the future as to what's coming down with HTTP3, quick over UDP and all the rest of it, being a full proxy is the only way that you're going to be able to stay relevant and continue to provide visibility into those encrypted threats.
And I guess being that full proxy also allows customers to very seamlessly and gradually move from one technology to a newer technology. Say, for example, they could move half of their application servers to newer technologies. I think you mentioned HTTP3, and do that in a gradual way because you've got the F5 managing all of these sessions in the middle between the server and the clients that are accessing them, right?
Exactly, and that's a really excellent point. So on this particular diagram at the moment, I'm depicting TLS 1.3 and the challenges associated with that and some of the benefits that we can provide. But bear in mind that that's just an example, right? As you mentioned, Rob, Quick and the like will have these same kinds of challenges if you don't have this kind of architecture and can solve for it. But TLS 1.3 in particular, so there's advice out from this Australian Cybersecurity Centre to say that all government services should be offered with TLS 1.3. Now, if your web application or your reverse proxy or whatever can't support TLS 1.3, by adopting this architecture in our solution here, what we can actually do is we can uplift the level of the protocol that's being negotiated on behalf of the real server or on behalf of the real client. So what I've depicted here is that on the internet side here, despite what the capabilities are of the clients or the servers internal to the environment, we're always going to negotiate the highest that we possibly can on the internet side. So we'll always negotiate TLS 1.3, even if a server on the back end can only support something like TLS 1.0. We also see this with things like kiosk systems. They tend to be old. They tend to be running Microsoft XP, out of support, out of date operating systems that just can't support a secure protocol. So what we can do is we can say, okay, they can still negotiate SSL or maybe TLS 1.0 with us, but on the internet side, on the low side, where we need high security, we're going to negotiate TLS 1.3. And we can only do that because we've got two totally separate sets of negotiations, two totally separate perfect forward secrecy key exchanges and the like, and the establishment of two totally separate encrypted tunnels on each side of our service.
And I guess does that same mentality to apply to things like access sessions? I know obviously there's a lot of SaaS, as you mentioned, getting rolled out, but I guess customers in general would have a mixture of newer applications and also applications that are potentially using older authentication methods. So that same proxy functionality can have a play in those sort of hybrid environments as well for access.
Yeah, absolutely, exactly right. So if you've got an old legacy application and it only supports form-based authentication, or maybe Kerberos constrained delegation or something like that, then we can act as an authentication proxy. So we can take one authentication mechanism on the public side and translate it to whatever's required on the service side. So a really common example is SharePoint won't accept a device certificate. It can't use that as a factor of authentication, but we obviously absolutely can. So we can take that device certificate in from the client that's trying to connect to the SharePoint service, and we can pull out the user principal name, do the authentication against the backend Active Directory service and the like, and then what we can do is then convert the transform the authentication mechanism to Kerberos constrained delegation when we talk to SharePoint. So the user comes to us with a device ID that SharePoint device certificate that SharePoint can't understand, but we authenticate on their behalf and log them into SharePoint as their legitimate user.
Yeah, brilliant. So I guess a lot of people are looking at public cloud these days. I mean, we've spent a bit of time talking about this next gen secure information gateway. But how does all this apply to public cloud environments where people are obviously looking to move a lot of their applications into these days?
So another great question. What I like to talk about this is in terms of being an architectural pattern. So once we've created this as an architectural pattern, and we've got the retrofitted the secure information gateway, if you like, to replace the old secure internet gateway, we've really taken on the attributes and characteristics we talk about here to create that next generation architecture. You can then apply it in any kind of environment that you need to, and we've got some examples. So one of the ones I like to talk about is it's probably a little bit dated for the ANZ market, to be fair, because a lot of Australian organisations have already dipped their toe into the water in terms of public cloud adoption in sort of one shape or form, if they're not all in, But I refer to this as the toe in the water one. So this is where you can consume public cloud services. So things like Azure and AWS or GCP or whatever, you can have interconnects into your data center services, but you don't expose any of those public cloud services directly to the internet. So you're effectively treating them as private infrastructure. So it allows you to assess the public cloud services, build out your capabilities, test out your new methodologies and all the rest of it, and understand those environments in a fairly low risk way, because you're not opening them up to the general public to be able to be abused, and they're still going through your gateway services. Well, hopefully the next gen gateway services, because you've modernized them. And so then you can think of it, well, what if we go beyond that and we want to take a step further? So this is one of the approaches that we see some organizations taking, whereas they don't want to have a single traditional gateway, if you like, inside their data center anymore, but they want to have it in a more centralized location that is much more highly interconnected and has really good quality data center facilities that they may not be able to provide in their own premises. Or they want to get away from owning assets, which is top on CFO lists these days. So one of the things that they can do is they can adopt services either from, say, someone like Equinix or NEC to have hosted environment where they can have the gateway infrastructure being located, and then they can leverage a managed security services provider like NEC to actually do a managed services over wrapper around that environment, so they can deliver a full outcome as a service managed gateway on behalf of the organization. And we see this getting quite a lot of traction, because what it allows you to do is you still have one gateway, highly available, of course, and all the rest of it. But it's a single gateway environment that provides the same set of security controls between all your different environments. We then have additional solutions that we talk about when we go down. So this is inter-environment security. So whether it's from the internet to public cloud, on-prem to public cloud, etc., you're getting the same controls inter-environment. And then we have intra-environment controls as well. So that's where we can actually go down and put additional security controls down into each of those environments, whether they're traditional data center or they're public cloud. And then the final part that is worth mentioning on this as well is that the next evolution of this is that you can actually do multi-cloud as well. So one of the things you can that we can cater for is the ability to have the same architectural pattern, the same set of security controls in different cloud environments. So you could have exactly the same gateway in AWS, and you could have another gateway in Azure. You could still have your data center gateway as well. But so there's full flexibility in terms of what you can deliver there.
Oh, that's excellent. Thanks for that, Dave. I think that's certainly shed some light on, I guess, the ways companies can sort of centralize a lot of these controls and maybe set themselves up for a more scalable way to handle their security, both for traffic going in and out of the internet, but also for traffic going in and out of these public cloud platforms. And I guess the value that F5 can bring along with other vendors. So yeah, really appreciate your time to take everyone through that. And we'll definitely have some more assets available. But please feel free to reach out to Dave or myself. Dave's details are up on the screen here, and we'd welcome any further engagement or questions around this topic.
Thanks very much for the chat, Rob. And yeah, please feel free to reach out, everyone. Thank you.
Thanks, Dave.